Hello and welcome to our final episode of this tutorial where we'll be verifying our AWS traffic encryption using VPC Traffic Mirroring. So, in our last episode, we have completed our AWS infrastructure setup that looks something like this. If you remember, we have our client that connects to the load balancer, and then the traffic between load balancer and ECS service is encrypted using self-signed certificate. Now, if you like to verify everything yourself, if testing is your second nature, you might be thinking, okay, you're saying that this part of the traffic path is encrypted, but why would we believe you? How can we actually check this? And this is where VPC Traffic Mirroring comes in. So let me show it to you in details. So we already have these two nodes deployed, ECS task and the load balancer, and they use HTTPS to communicate between each other. Now, the way the VPC traffic mirroring works is we need to deploy an EC2, which will be our mirroring target, and then configure ECS task, which is a mirroring source, to copy all of its inbound and outbound traffic and send it to the EC2 instance. Now, when we'll be analyzing this intercepted traffic in our EC2 instance using tcpdump tool, we expect for all packets to be encrypted. We should not see a single packet that is in plain text. So the idea of the test is quite simple actually. But before we get there, I would offer you to do the same test on unencrypted traffic. What if ECS and LB would be communicating using plain text HTTP protocol? How would the malicious user that can access our packets through the EC2 instance, how would this malicious user see these packets? Let's do this experiment first. The steps for deploying this unsecure project would not be much different from the steps that we had earlier. The only thing we need to change is the task definition. We need to remove an Envoy proxy container from our ECS tasks, and we need to change a target group in our load balancer by changing port and protocol from HTTPS to HTTP. But as any tech person, I'm quite lazy, so I'm not going to do it all manually. Instead, I have created this project in Terraform, in this project here, and I've created a separate branch that is called unencrypted traffic. All I need to do is to switch to this branch, and then as you can see, it's all been done for me already. And I have also created some GitHub actions that I can use to deploy this unsecure infrastructure. Well, it's quite secure. The only thing that is unsecure is traffic between a load balancer and ECS. So let's do that. Let's give it some time. Okay, as you can see, the build is green. So the next step would be, we can skip the RSA cert step because obviously we're not encrypting our traffic. So the next step is preparing Docker images. Okay, so this run is green as well. Let's just double check that our website is available. Brilliant. It is up and running. And let's just go to AWS console to see our ECS. We just want to double check that our task has only one container running. Yep, as you can see, now it has only one container and the envoy is not here. All right, all the setup is done now. Let's get to the fun part. To establish our traffic mirroring session, we need 4 things. First one is a traffic mirror source, which is our ECS task. To be more precise, our ECS tasks Elastic Network Interface, or ENI for short. And it already exists, so we can tick that. The next one is a target. It will be an EC2 instance that we are about to deploy now. Next one is filter. We need to filter what type of packets we will be copying to our target. And finally, a traffic mirror session, which is just a relationship between a source and target node. To create our target, let's go to the EC2 console. And let's click on the Launch Instance button. So we need to give it a name, something like mirror target. Amazon Linux CMI will do the job, so keep it this way. T3 micro is fine. Then we can use a key pair for a secure connection. Don't forget to edit your network settings. We need to change the VPC to the one that we've created earlier. Private subnet is fine. Yeah, we need to create a new security group. Let's call it something like Traffic Mirror Target Security Group. Let's give it a meaningful description. Okay, now we need to think about the inbound and outbound security group roles. So we need only one inbound rule, which would be all traffic from the security group of our ECS group. That's right. That should be enough for now. So let's launch it. What is our testing scenario here? Our scenario is that we have a new employee who happened to be a malicious user, right? And unfortunately, our security team has misconfigured their IAM policy. All right, so, and this user, Rami, he's trying to sniff packets on our internal traffic. So what would be their steps? First of all, they would authenticate. And as you can see, they still have a lot of access denied. So our policy is not that bad, but it is not good enough. And then Rami would go to the VPC to create a traffic mirroring session. But before he creates that, what does he need to do? That's right, mirror target. He needs to configure that first. He chooses the network interface, and our target would be this one, ENI of our EC2 instance. So let's create it. Target is here, brilliant. Next step is to create mirror filters to filter out irrelevant traffic, to keep the noise out. So let's do that. Let's start with the inbound rules. And our first rule will be about capturing unencrypted traffic packets. So this will be the port range for our load balancer, and this is for the ECS task, in our scenario at least. So our application is listening on port 8080. The source can be from anywhere, in case it's talking not just to the load balancer, but to other services, for example. And the destination will be a private IP address of our ECS task. Let's quickly find out its value. So we can go to cluster, service, tasks. Here it is. And then we need to make a note of its ENI because we'll need it in the future as well. Okay, let's go back. Add subnet mask of 32. And here we go, one rule is ready. Let's create a second one, pretty much the same, but for the encrypted traffic that we'll need in our second test. So everything stays the same apart from the destination port. Alright, and now let's do the same for our outbound rules. First one will be HTTP from our app to all ports, and from our IP to all IPs out there. And same one for HTTPS. Okay, that's brilliant. We have our filter, we have our target, we have our source, so we are all set and ready to create a mirror session. The mirror source would be, let's go to ECS task and check it. Here it is. Please don't confuse it with the other ANI, because remember, we have two tasks and two ANIs. If you're filtering traffic for this IP, please keep the same ANI ID of the same task. So where's this guy? Here he is. Nice. Mirror target. That's the one. Session number 1 is fine. Apply our filtering and let's create it. Okay, so everything is ready for us to go to the EC2 task and try to sniff the packets. So let's go to the EC2 page. Here's our target. Let's use SSM Connect. And here we are. We are inside. So now we need to use tcpdump to capture the filtered traffic. First, let's see what type of network interface this EC2 instance is using. So it would be ENS5, and then this is the command that we need to use to see the packets. The only thing, please change the interface, ENS5. What we say here is run as root this command line packet analyzer, which is tcpdump, using this network interface, ENS5, that I retrieved from this output. And then we say not to convert host addresses or port numbers to names, to use a very verbose output, and then print packets in the ASCII format. All right. And finally here we need to pass the ECS task IP. So let's copy paste it again. Okay. Brilliant. We are actually capturing the packets. Let me send some requests to get more packets. Okay, so I stopped the tcpdump run after 10-15 seconds max, and you can see that we have captured 113 packets within this time period. And what I can see already is this plain text message here. Do you recognize it? Does it remind you of anything? It was sent from this private IP address, which belongs to our ECS task, to this address, which is also a private IP, and we can assume that it's a load balancer. And yeah, here's the message. Plain text, unencrypted, begging, shouting, please read me. VPC Traffic Mirroring is amazing. This tool has so much character. And if you combine it with the tcpdump, it's sheer power. Alright, so our next test is to run the same VPC traffic mirroring scan on the infrastructure setup that we have created in the last 7 videos, where we have encrypted traffic between ALB and ECS, and our expected result would be to see no plain text messages. If you have missed previous videos and don't want to follow the whole tutorial, I have prepared several workflows for you in my ECS self-signed repository. So all you need to do is to go to the deploy infrastructure workflow and run it on the main branch, and then do the same for creating certificates, then preparing and push Docker images, and finally deploying traffic mirror test. So I've done that, and if we go to our web app, it should be behind the proxy now. And yeah, that is the case. Brilliant. So let's run our traffic mirror test on the encrypted traffic now. And this is our new traffic mirror session, and our source is this ENI now, so we just need to track which task does it belong to. So let's navigate to the ECS page. It ends with 43D. So it belongs to this task with this private IP. So let's copy it or take a note. Okay, and now we are ready to SSM into our EC2 instance. Here's our command. We just need to replace the IP address. Let's run it. Okay, let's leave it for a minute or two. I'll also send some requests through the URL. Okay, I have stopped the run. As you can see, we have captured 225 packets. That should be more than enough. And what I'll do now, I'll just copy paste it into our text editor. And if I start searching for a substring from our payload, like for example, I'll start searching for hello, you will see that the editor is unable to find it, which proves that all of our packets have been encrypted. So our test is complete here, and to exercise this quite simple, but at the same time very efficient exercise, all you need is a user like Rami Malek that I have here, and their policy is so short, like that's all permissions that they need. As you can see, no wildcards apart from resources, but that's only because I felt lazy. I could make it more narrow as well. These permissions, which are about like a bunch of EC2, a couple of SSM and ECS permissions, is enough to sniff packets of your internal traffic. So thank you very much for watching, guys. If you have any questions, ask me in the comments, and I will see you later.